In programming, recursion is a technique where a function calls itself directly or indirectly in order to solve a problem. In this example, the function's only job is to laugh, and it does so recursively. But since there is no condition, the program will be in the laugh state forever. This will cause a Stack Overflow error, where the runtime simply tells you to stop yapping. To avoid that, recursive functions are given a base condition which states when to end the process and a simple recursive condition telling it when to start. It's like hearing a joke and laughing only when it's actually funny. And now moving forward, the most common example of a recursive function is the factorial problem. The factorial of a number is the product of all positive integers from 1 up to that number, and by definition, factorial of 0 is 1. Now any factorial can also be expressed as the product of the input integer and the factorial of the previous number. This is why we are calling the factorial function for the n-1 part only. If n is greater than 1, then the recursive case is called. This breaks the problem into smaller pieces, gradually reducing n until it reaches the base case, just like peeling an onion layer by layer. For example, if we consider the factorial of 3, then the recursive case would obviously call the factorial of 2 and then 1, and at the end, the results are returned back up in the chain. So, the factor of 2 becomes 2, and multiplying this with 3 results in a 6. Another example is the sum of array elements, where the function simply takes an array of numbers and sums it arithmetically using recursion. Two function arguments are needed, the array and its length. And for an empty array, since the length is 0, so we don't have to sum anything. When n is greater than 0, the function returns n-1 or the last element of the array plus the recursive sum of the first n-1 elements. This is like the factorial solution, further breaks the problem into smaller pieces until the base condition is reached. This might not sound practical, but it's used in functional programming where recursive solutions are preferred, in data processing problems, and while summing the values of all nodes in a binary tree or other tree traversal problems.